Okay, so part 2. As I mentioned, we've got our simple program here. We're going to want to have a orange flashing light. Now, rather than saying amber light on, amber light off, so we could demonstrate that, because I'm going to need to do it in a second. So we're going to have it this time for just half a second. And then this one, no lights on. We haven't used that one yet for half a second. So really, to have it flashing, I'm going to copy that and paste that 5 times. Now, you notice already we're going to have quite long code even for a simple program like that. So there is a neater way of doing that. And that's what this one here is, for loop. So if we use this one, you'll notice in the heading it says looping and repeating. Might see where this goes. So we can basically say, if we put it within this loop here, for loop, and if we double click on it, we can say either for a period of 10 seconds, for example, or for a certain number of times it repeats this function. So we might want to just say 3 times, let's say. Okay. There are more advanced things like counting alternate loops, and also you might want to use a variable. Now we're going to cover variables in a second with the problem of how to not let the traffic light change until a certain amount of time has passed. I'll show you in a second. Anyway, that's one way of doing it. There are lots and lots of other things which I will cover in the more advanced Circuit Wizard video, which will help you maybe for slightly more advanced pet feeders or something on your NEA. It's a quick lowdown of all of these. I say quick, probably about 15 minutes long, but we'll just go through all of these functions, talking about what they can be used for. And then there's an example helicopter project that uses quite a variety of different things. Those of you who might want to make quite advanced games, it's worth looking at that, because that obviously is a game itself with its own hardware. But anyway, back to the traffic light. So we've got this thing here. We can slap this in after the red light and then back to green. Now, for some reason, you might want to use the amber flashing light in 2 parts of the program. You won't really need to on this traffic light sequence, but let's say if the button's pressed here, then you want this to happen, and then when it's pressed again down here, you want this to happen. What we can use there is what's called a subroutine. Again, I'm going to put it in this line. So I'm going to call a subroutine and then return at the end of it. So we're going to call this flash amber. Okay, now if I use the call button here after the red light, double click on that, I've got the options of all the subroutines that have been drawn out here. So we've only got one here, flash amber. So that means when we get to this bit of program, it will do this bit. So like I say, if we have it further down the line, rather than writing this out again, I can just put it further down the line. It just makes long programs a lot neater. Let's have a quick look at that, see if it works. No, okay. I need to tell it how many times. It should have worked for 1 to 10, but we only want 1 to 3. 1 to 3. Okay. Yeah, it works. I don't know why it didn't last time, but there you go. So, press the button. Now, you might notice it doesn't always work. You've sometimes got to hold the button down just because it's cycling through much slower than it would do in real life. Just gives you enough time to see what's happening, but sometimes just hold the button down. And that seems to work fine. So yeah, that is the most basic exercise, and that will give you kind of minimum marks, just copying what I've done. For those of you that might want to play around with trying to get the red, and obviously you want to have the red and the green man output as well, so you want to put a few more outputs on. But also, like I said, we're going to look at the time delay. So now we'll just look at clock. Clock down here. So it's just this one button here. It's one flowchart box, but it has 3 different functions that are useful. So we've got reset the clock, which is what it is. So that means each time we have a cycle, obviously the clock wants to start counting when the traffic light is green. And you don't want to turn it amber, let's say, if it hasn't been green for 10 seconds, for example. So if we drag out another clock, we're going to start a clock counting, and that should do. That's all we really need. We don't need to stop the time. Will come apparent in a bit. So we'll just drag that over here so it's out of the way. We might need a bit more space here. You can see why having A3 is better than A4, just so that you've got plenty of space to lay it all out. So green light is on. So when we think about it, the sequence is finished from last time. The green light is on. The time, now if you think about it here, if the button's not pressed and the clock is reset every time this loop happens, then it will never count. So really we want to make sure that clock is not reset. You get a bit of a confusing thing like that. We want to make sure that clock isn't reset every time this state is achieved. But when it's finished flashing amber, we do want to reset the clock. So we're going to put that above reset or into it like that, it doesn't matter. Okay. Now we could even put start clock here. We could put it here as well. It doesn't matter if it's keeps saying start clock each time it goes round, because it's not actually changing any state. Clock is already started. It's just tidier if it's there anyway. Okay, so is button pressed? Yes. Now, have we only pressed it 3 seconds after this happens? Maybe. Let's see. We need to ask another question. So in other words, this will only happen if the button has been pressed and we pass 10 seconds. How do we do that? We use this thing called compare. Those of you it's a triangle here. Compare. Okay. Now, time is a variable. It's basically a bit of data in the chip that keeps accumulating, but it changes. Variables are really useful in PICs and any form of program, because so you can store information. You could potentially count the number of times a button's been pressed or something like that. Variables are really quite important for slightly more advanced code. But in this case, our variable is time. So if you look here, we've got 26 type, well, 29 if you include those types of variables. Our variable is down the bottom. So time, is time greater or equal to 10? So you see, you could compare a lot of other variables. So have you been pressing the button 10 times? If we've been adding up the number of times the button's pressed, we might add 1 to J or something like that. We'll cover that in the more advanced functions in the other video. But in this case, time, is it greater or equal to 10? So has 10 secs passed? Okay, so if it has, then we can do our traffic light sequence, and if it hasn't, we carry on looking. Okay, so there you go. I've given you most of the answers of how to do the most basic, the first exercise. Like I said, you want to put the red and green man on really to get your marks for that. And then I'm just going to give you one little heads up on how to do the next project, which is the dice. Now, what is a dice? It is a random number generator. So we use random. So that means we're going to use this variable thing. Okay, so we are going to call variable A. We're going to give variable A a value. Now, I could put this in the traffic light sequence, even though, because we've got a traffic light built. So, yeah, I'll demonstrate it in a minute, actually. So, in this case, with a dice, we're going to have 1 to 6. So, it's every time it passes through this command here, it's going to assign a number from 1 to 6 to variable A. Okay, you will find that if you can have odd commands just floating about in your workspace, so long as it doesn't interfere with this program here, it should be okay to work. So you should notice. Quick demo of our last thing. So green button, press that, nothing happens until 10 seconds is passed. Okay, you've got 10 down there, so it's gone past 10. Now you might find actually that runs faster than the counter on it. It is a little bit clunky sometimes. Now, one thing also you can notice is inputs and outputs. So if you click on a flowchart, D0, you can choose to press the button from the flowchart by just clicking there. That's quite handy. Or you can also look at the digital inputs and outputs here, so you can see what's showing on the output and the input. Like I say, 5 is an input that is always used, so as not to reset the chip. And also we've got this variable time. So if we look at the variables, it's not on there, and several monitor panels at once is sometimes useful. Okay, forgive me, it's not even on there too, but you could actually assign a variable to be time as well, so you can watch it simultaneously. Right, so that works. Now I'm going to just keep some of these commands. So let's keep the button pressed. Let's not worry about the time anymore. So this is going to be just a quick demonstration of random values. So we're going to just have, because we've only got 3 things plugged in, we're going to have 1 to 3. So is button pressed, and this time we're going to have no lights on. Okay, I should change that caption. So is the button pressed? Yes, when it's pressed I'm going to ask it to deliver a random number. Now let's get these out. Again, I don't need to worry about that. So what happens here? So we're going to use the compare thing again, but this time we're going to look at the variable value. So here, I double click on this. Is A equal to 1? Then I shouldn't have deleted out all those red on, but you get see where this is going. So if it's 1, we're going to do green on. Okay, copy that, paste that, stick it there. This time we're going to just change that to 2. You don't always have to write captions, because sometimes it will automatically just caption what you've asked, what you've commanded. And then here I'm going to just have the amber on. and then green. Oops, if you have them too close it will automatically link them, which is not what we want here. So here we're going to have 2, and here if A is 3. So if it's not 1, then it asks, is it 2? If it's 2, then we're going to go down here. Now you notice it's already kind of got the yes and the no the wrong way around. So if you right click there, swap yes and no, and that way it's correct. Now what if it's not 1, 2 or 3? Well, we've only asked it to call 1 to 3, so that will never be the case, but you still need to just loop it, just otherwise it's not clever enough to realize that. And again, we might want to just have a pause command on this, just so that you've got a quick little indication. Not 3 seconds, let's do ½ second. Okay, and then it goes round after ½ second, switches them all off. Quite often you'll find you write a program and lights stay on because you've forgotten to turn them off. It's often the case. Anyone who pays energy bills is probably constantly reminding that too. Anyway, let's see if this works. No, because we've forgotten to say what happens if it's not pressed. Nothing. Just keep asking. Okay, so as expected, no lights on. Press the button, got random red, random yellow, random green. Can you see there? It quickly went from green to red. If I'm holding it down, obviously still pressing it when it's gone through the cycle. So how do we resolve that if we don't want what's called what is sometimes referred to as switch bounce? Not in this case, but if this is happening really quickly, obviously you want to have a very slight pause after pressing it, just to give it enough time to register that you've released it. Maybe 200 milliseconds or something like that. Anyway, ½ second obviously is not enough time, so how can you do it? Well, you could wait until it's not pressed. So here we could ask, is D not pressed? Yes. Well, if it is, we carry on going here. If it's not pressed, then we answer. That could do it. So in other words, that will carry on in the loop once you've released it. That's one way of doing it. Oops. Can be a bit fiddly this. Like I say, it's always good to have plenty of space. So go for A3, whatever you're doing. Sometimes A3 is not enough for advanced programs. There you go. Let's test that. So press it, hold it down, it stays green. Let go, then it goes on to the next as no lights. And that works fine. So again, a bit of a kind of bare bones example of how you might program a dice. Hopefully some of you will get quite advanced. Maybe some of you, I mean, you could see the potential if you really get into your teeth into programming. Those of you who really want a challenge might want to have a dice where you've got the option of not seeing the same number rolled twice in one go, for example. You can't have that in a real dice, but in an electronic dice you could. You might have to think about some kind of option menu system, which is making a very simple product such as a dice very complicated. But you'll see, especially if you start looking at the other two videos that I've got on Circuit Wizard, it is actually a very powerful program, and you can do a lot with it. So there you go. First stepping stones for your first 2 exercises on Circuit Wizard. The third one is to make your own game. So you could be thinking about something like a reaction timer. Anyway, I'm on hand to give you any support if you're stuck on anything. Go and watch the more advanced Circuit Wizard programming functions that I've done already. And then there's one other resource that I really recommend that should be on Moodle, and that is plagiarizing another teacher called Mr. Winter, Rob Winter. He does some really good exercises for his Key Stage 4 GCSE systems and control students. They also use the same system, Circuit Wizard, and it's a really good intuitive resource online. So plenty to look into to improve your Circuit Wizard skills. Best of luck with that. Thank you very much.